Okay, for today's warm-up, I'm going to have you copy all of this work and the 5 words to show me that you were listening. Here we go. Again, if I give you the function f of 1, that means I'm giving you the x number to plug in here and do the math. So here I go. The function at 1 means taking that x and replacing it with that 1 right there. So 3 times 1, I'm going to take that answer and multiply and then subtract 2. So the function at 1, or when I plug in x is 1, gives me the function of 1 is 1. First word is red, red. And of course that point is an x and y coordinate. When you plug that in, that automatically is the x number, and the math that you do once you plug that in is the automatic y number to graph. So that coordinate, when I plug in 1 for x into that equation, that gave me 1 for y. I should be able to plot that now. Now if I plug in 2 into that same equation where that x is, now I'm putting a 2 because that's what this is telling me to do. Gives me 3 times 2 minus 2, which means the function when I plug in x is 2, or f of 2, is 6 minus 2. The function when I plug in 2 for x spits out 4 for y. That is my coordinate. Again, that number you plug in is the x coordinate. That number you get when you spit it out doing the math is the y coordinate. Let's do one more. F of 3. So 3 times, second word is fish. Fish. So plugging in 3. 3 times 3 minus 2 gives me the function at 3 is 9 minus 2, or the function when I plug in x is 3 is 7. Again, notice that when you plug that in, that automatically is the x number, and this math that you do gives you the y number. So that point is going to be 3, 7. I need you then to be able to graph those on a graph, where this is your x number, your up and down really is your y, or we could start to call that f of x if we're using function notation, same math though. Plot them. So 1, 1 means right 1 on the x-axis, up 1. That's the point 1, 1 right there, over 1, up 1, be able to graph. 2, 4 is right 2, up 4, 2, 4. And then the last one is 3, 7. 1, 2, 3, 4, 5, 6, 7. 3, 7. If I draw a line through these and I'm accurate, there's things that this graph is going to be telling me. Like this right here, where it's touching the y-axis, that's going to be your y-intercept. Let's get this graph set up. So it looks like the way this graph is set up, right here, this coordinate is my y-intercept. That's 0, negative 2. I can see on this line, every time I go over 1, I'm going up 3. That is the slope of this line. We're going to be using that y-intercept and slope. Third word is wave. Wave. All right, last problem. For this, these are sequences. This is a big part of this quarter, being able to recognize a mathematical sequence. Knowing that, looking at these patterns, if I could go from 3 to 5 and 5 to 7, if I could see that I'm going up by 2 every time, adding 2 every time, adding 2 every time, that means this sequence is what we call an arithmetic sequence, because it's adding or subtracting. If I plot these points, which we're going to do, it will be a nice straight line because they keep increasing by that same 2 each time. If I look at this next pattern though, this one is not adding. You could tell because this is going up by 4, and then this goes up by 8, and then this goes up by 16. If those numbers are not the same going up or down, that's not arithmetic. This one is a times one. I'm going to times each number by 2. 4 times 2 is 8. Times 2 is 16. Times 2 is 32. So if I'm multiplying each time, let's write those a little bit better. If I'm timesing each time by 2, that makes this what we call a geometric sequence, which means the graph will be curved like that. Starts off straight but curves. We also call this exponential. Write these down. This is an exponential sequence, grows exponentially. That straight line we call a linear, like a straight line. And knowing these patterns, you can also go forwards and backwards, reversing the patterns or continuing with the patterns. You need to be able to do that. So that means if I'm going to the right of 9, fourth word is whale, whale. If I'm going to the right of 9, I just keep adding 2's. 9 plus 2 gives me my next number in the sequence, 11. 11 plus 2 gives me my next sequence, 13. Plus 2 gives me 15. So I could keep adding 2 to go to the right. But know when you're going to the left, you're doing the opposite. Going this direction, the opposite of adding 2, subtracting 2. And again, that makes sense. 7 minus 2 is 5. 5 minus 2 is 3. 3 minus 2 gives me 1. 1 take away another 2, if I get that back. 1 take away another 2 gives me negative 1. So I could go either way on my sequence. And of course, that makes sense. Because if I have negative 1 plus 2 gives me 1. 1 plus 2 gives me 3. Same with the timesing ones. You could go both directions. Keep timesing by 2 to the right. This will give me 64. And then whatever that number times 2 will give me the next one. Maybe, let's see. Let's use a calculator. Gives me 128. So you could continue the pattern to the right by timesing, but careful on this one, going to the left. The opposite of timesing by 2 is dividing by 2. So we show dividing by 2 going to the left. That gives me 4 divided by 2, which is 2. 2 divided by 2 is 1. And then you're going to see, we're going to not write division on these. We're going to say, instead of writing dividing by 2, I could say that's the same as timesing by the reciprocal of 2. So the reciprocal of 2 is 1/2. That is the same as dividing by 2. We're going to be hammering that because we don't want you to do division. So geometric sequences, timesing. Arithmetic sequences, adding. I'm going to have you try a set on your own. Actually, let's just stop right there. And then the fifth word is puppy. Puppy. So we'll be reviewing this today. Good luck.